What's going on, everybody? James here from Artificial Entertainment, and today I'm going to show you how to be able to set up the adjustable throw and call system. So let's go ahead and dive in. So the character setup is pretty straightforward. Before we start, setting up behaviors and stuff. But once you've added the asset to your project, you can open up your character blueprint, and the first thing we're going to do is up at the top here, you're going to see class settings. So if we click on this, go to the details panel, under interfaces, you'll see implemented interfaces. If we click on add, we can type in ATCS and you'll see the player BPI right here. So we'll click to add that. And then we also need to add the component itself to the player. So we're going to go up into the components section here on the left side, click on add, and also again type in ATCS and you'll see the component, and we're going to click and add that as well. Now from here, we're just going to navigate to the event begin play section, which for me is looks like this because I'm just using the third person template character. And we're going to grab and drag a reference to the component into our graph, and then drag off and type in set owner data, because we're going to give the component some initial references it's going to need to be able to do certain behaviors, such as the character reference, which we can give it by pulling off of this and typing in self to get a reference to self. And the actor viewing component, that's going to change based off of your perspective. So if you're doing third person, first person, anything that your perspective is going to be from behind the weapon, then you're going to be using your camera. So in this case, we are going to be using the follow camera. However, if you're doing a top-down or side scroller, you're going to probably want to make a secondary scene component and plug this in instead, maybe attach it to your character mesh or something. But realistically, you're going to want to make sure that it's something that's going to be in the orientation that you want the throw to go, because this is going to be the component that is going to get a transform for the start of the throw orientation. So for anything that's behind the character, you're going to use the follow camera, but anything that the camera might be a little bit offset, like a top-down or side scroller, you can use a scene component object and plug that in here instead. Now, the last thing that we need is some sort of actor reference. Now, this is something that you might already have in your blueprint. It's just something basically to say, like, we already have something in our hand to be able to throw. Now, whether you have this or not, it's okay. We can add it in really quickly by going and adding a new variable. And we're going to set the name to throw actor. And then we're going to change it from a Boolean type by clicking the drop down. Search bar, we're going to type in actor, scroll down, and under object types, you'll see actor, then object reference. So now we have an actor variable we can use to be able to save information for like when we're recalling and throwing and doing all that kind of stuff. Item setup can be, realistically, can be really cool. There's a lot of different behaviors that you can define and adjust and create utilizing the different parts of the system. But no matter what type of behavior you're trying to create, there are a few things that you do need to make sure to have. Number one being a blueprint, some sort of actor that can contain the information. Number two, a mesh item. This can be a static mesh or a skeletal mesh. So for this example, I'm just going to quickly add a static mesh here to my blueprint, so which goes static mesh, and we'll add that in. And then for the mesh type, I'm just going to set it to a knife. I've got a couple of mesh packs added into my project, but that's all it is. It's just a simple static mesh. You can see here, just a simple combat knife. Now, we also want to add a collision object around the item. Now, this can be whatever you want, capsule, sphere, whatever. I'm going to use a box collision though, just because it does fit the item a little bit better. And I'm going to take it and parent it to the mesh. So this way these items stay together. So wherever the mesh goes, so does the box. And then just, get a rough size scaling. We are going to adjust this later once we start defining some behaviors, but just get it kind of within reason so that way it's surrounding sort of the middle of the item. I think that'll do good for right now. So now that we have the mesh, the actor, we have a collision item added to it. Now we're going to add the blueprint interface, which is realistically where all the magic happens. So we're going to go up to class settings here. And in the details, down to implemented interfaces, click on add and look for ATCS, and we're going to get the item BPI this time. Now, once this has been added, if we go to the My Blueprint section, under interfaces, you'll see these new events being added. And the first one we're going to open up is going to be under set data and go and open up the get throw mesh items. So if we double click and open this up and get to the components tab, we want to take that static mesh that we created, or a skeletal mesh if you're using a skeletal mesh, it really doesn't matter. But we're going to click drag into our graph and we're going to plug it into the throw item mesh. Now we're going to leave the attach or the collision items here, the sim physics and attach. We're going to leave those blank for right now, but we want to make sure we give it a mesh reference at the minimum. Then the next thing we're going to do is go into the event graph, go back to my blueprint, and we're just going to kind of condense this menu here and go to primary events and then main. Now we're just going to double click the ATCS data pass through as well as the set component status here, add these both in, and then the pass through here, you see the overlap ignore actor. We're just going to right click and promote this to a variable because we're going to use this later, but we want to save it now. Now for the set component status, we can actually just right click and type in update throw components, and you can see the throw action functions update throw components. So we can hook up the execution pins here, the ATCS reference into the comp reference, and the two booleans we can hook up like so. Now for the self reference, we're just going to pull off and type in self to get our reference to self. And the mesh is going to be that static or skeletal mesh, whichever you created. We're just going to drag it into our graph and plug it in just like that. So once we've added these two events in here, and we have our mesh, we have our collision, we have the actor, so we're good to go. Now we can start setting up some baseline behaviors with our item. So to be able to set up a recall behavior or a call behavior, I guess, is actually very simple, but it is entirely up to you how you want to search for the item. So the system carries all the information that you would need to be able to have the item go from point A to point B smoothly and dynamically with some nice movement options. But how things start and how things end are entirely up to you. So the first thing is we need to make some sort of function to be able to find items. And I have one pre-made here just to kind of save time. And it's just a simple sphere trace. So it's going for the follow camera, going forward, and then if we do hit something, checking and seeing if it has that item interface that we added earlier. If it does, then we're going to go ahead and save that actor value to as a local variable. And this is off of a sequence, so it's doing this first, and then at the end, returning back with a possible actor value. So this is a very basic function. And if you want to learn more about line traces, I do have some videos on my channel. This way you can learn a little bit more if you're still learning and you don't know how to do something like this. But you can also use overlap events, find nearest actor, however you wanted to do it. Now, the other thing we're going to do is set up a quick input. Now, you can use the enhanced input event, but for this, I'm just going to use the simple keyboard event R for this input. Now, we do have this throw actor, which is, again, it's going to be the actor referencing whether or not we already have something in our hand. So what we're going to do is we're going to get it and then right-click and convert it to a validated get. The reason why we're doing this is because we want to know if this is valid. So if it's not valid, then we don't have something in our hand, and we're going to allow the trace to function and go through. However, if it is valid, we don't want to do anything. Now, from here, because of the way my function is set up, and it could return back a null value or, a blank actor return, I'm going to pull off of this pin here and get an is valid check, just to make sure that it's providing back a valid actor. Now, from here, all we need to do is get our component, get the ATCS component, pull off, and we're going to go with initiate, and you'll see recall item right here. So if it is valid, we'll plug that in. Now, the recall item reference is going to be the found actor, however you found it, whether it be through a trace or an overlap or a find nearest actor, whatever you're doing. It could also be something that you already threw and you want to recall back to you through using a saved reference. It's realistically entirely your choice. And then the recall target mesh reference is going to be wherever you want the item to be recalled to. Now, this can be a static mesh or skeletal mesh, but I do recommend something that has a socket on it just to give it some really precise attachment. Now, for our mesh and this example, we're going to be using the character mesh and we're going to be having it go to the hand. So I'm just going to grab my character mesh here from the components and plug it in just like that. So now we've created the ability for the item to be called and sort of move to us, but we haven't created the ability for it to attach yet. And that's because there's actually something inside of the system that we can use to help this along a lot better. So we're going to go back to the item. So this is the knife blueprint that we were making earlier. And if we go into the My Blueprint section under interfaces, go under set data, and we're going to open up the set item recall params. Now under here, we can set a lot of different values, such as the recall speed, which I'm going to set to about 850. And the recall midpoint offset direction is essentially the call is going to have a bit of a curvature as it comes to you, or comes to wherever the point you assigned is. And you can define what that curvature is going to look like, if it's going to use the right vector or the up vector. So for me, I'm going to keep it as the right vector, and then the offset amount, you can actually use negative or positive values to be able to have it go left, right, forward, or back. Or I'm sorry, left, right, up, or down. So for me, I'm going to set it to the right vector at -50. And then the recall target socket, this is the reason why we came over and set this up first, because we can now assign hand_R as the socket, but if you have multiple items and multiple different sockets you want to use, you can use this to be able to assign the socket. And now if we compile and save and go back to our character, we're going to go to the My Blueprint section under interfaces, In the beginning of the video, we added that ATC as player BPI. So this is where these events are coming from. And if we double click on the recall end, add it into our graph, just pull it over to our recall execution here. What we can do is we'll get another validated get. So we'll just click on that and then Control D to duplicate it. And if it's not valid, then what we're going to do is set the recall actor reference to the throw actor. So we're going to get a set reference and then plug it in off of the not valid. So basically, if we already have something, we don't want to override it basically. And this is going to create essentially like a first come, first serve for the attachment. So if you accidentally have 2 items coming back to you, only one of them will attach. Now from here, we can pull off of the pin for the throw actor, and we're going to type in set recall, and you'll see the set item recall params. Now this is that function that we just set the information in the item. So this socket here can now be used for something like a attach actor to component node, because then we can take the throw actor, plug it into the target. The parent is going to be our mesh. So we're going to go into the component section of our character here and grab our mesh, put that as the parent. And then the socket name is going to be the recall target socket. So this way we can have the item tell us what the socket is supposed to be versus having to create some sort of subsystem for socket selection. So just something to point out because I thought this was a really nice additive because I'm always creating socket subsystems, and this just made this part of it a whole lot easier. Now, one thing I just do want to point out very, very quickly before we actually show the demonstration here is that from here to here is entirely up to you. Again, you can do whatever you want to find the item. This is the part that the system is doing, right? This part here, again, this can be whatever you want. You can use, because this is an actor reference, you can use tag checks. You can also use your own blueprint interfaces with like enumerations or string checks and things like that to be able to even further make the selection or things like that more evolved and advanced. So because you've got a nice actor pin here, there's a lot of things you can do. This whole thing here is purely just example. So if we go ahead though and compile and save, and then we'll just drag an example item here into our graph, and I'll just hold Alt and drag over so we can get 2 of them. And if I hit play and then I press R, which is the key that we binded to the event, you can see that it moved over to us. However, the attachment looks like it messed up, and I think, yep, okay, that's why. So make sure to set the location, rotation, and scale rules to snap to target. If you set it to relative, well, what you just saw will happen. So we go ahead and hit play now, and we find the item. You can see now it actually attaches. It looks like it's in my wrist, but that's okay. Because if I had an actual socket assigned, I could rotate the item and make it assigned and, fitting accordingly. But because we're just using the hand here, that's ultimately why it's attaching that way. But again, you can do whatever you want with this. This is just an output event letting you know the recall is ended. The attachment is entirely up to you, and you can do a whole bunch of other things other than attach as well. And from here, once you have that set up, it's just kind of defining the parameters, right? Do you want it to rotate on recall? So if you do, check this little box under the set item recall params and the item itself under the set data. So if we go and do that, maybe give it a slight rotation for the recall rotation rate. If I go ahead and click play and then bring it, you see how it rotated back to me. Now, the other thing I want to show you guys too is if I do this and this, you can see they're both coming to me, only one attached. So that's where that blocker that we created here. So if I go back to the character into the event graph, this validation get, that's where that's creating that first come, first serve based attachment. So this is just, recommendations, that's all. But that's really all you would need to do to be able to set up the call system. And from there, your imagination can run wild. Now, to set up a throw behavior, it's pretty simple, but there's a lot of different ways that you can do it. And the way that we're going to do it in the beginning here is just going to be using a simple montage to be able to actually trigger it. So this way it can be animation driven, but you might not have the cancel and all of the other features that are built into the system as well. So the first thing we're going to do is in the character blueprint here, we're going to find some empty space and we're going to get a keyboard event E because we want to be able to do this off of an input event. And I'm just going to use E for the throw just to make it simple. Now, if we go to my blueprint, we're going to grab the throw actor, which just to reiterate is the actor referenced by something in our hand, something we're going to throw. So this is going to be the actual actor we're going to throw. So we want to get it, right click, promote to a validated get. This way we can make sure that there's actually something there before we try to do anything with the throw. If it is valid, we're going to go up to the components tab, get the ATCS component, pull off and get initiate, and you'll see initiate throw. Now, don't worry too much about the whole the throw state or the instant execution. Just plug in the is valid into the execution pin here, and then the throw actor into the throw actor pin, or the output throw actor into the actor pin here. So this is just telling it this is the actor we want to throw, and the rest of the stuff won't matter for montage execution. Now, because we are adding and using a montage, we need to go and add a play montage node here at the end. And we also need to just go into our components and grab our mesh to plug into the in-skeletal mesh reference. So this is just, what's the mesh you want to play the montage on, basically. And for the montage to play, I have this simple throwing montage here. So I'll show you guys that really quickly here. So if I bring it up, you can see that it's just a basic, he kind of grabs, throws, and then resets back into an idle. So it's a nice little loop, very simple. And what we're going to do is we're just going to scrub forward, and we're going to look for right around where the character releases the item. I'd say right about, maybe right about here will be good. And then we're going to go under notifies, right click, add notify. And then under the selection list here, you'll see AN launch projectile. So we'll add that in, click on save, and then we're going to go back to our character. Now at the end of the execution here, what we want to do is also make sure to reset the throw actor. So we're just going to grab a reference to it, get the set node, and hook the execution and leave this blank. Because this way, once we throw the item, it's going to then set it back to null. So now from here, we're going to compile and save, and we're going to go to the actual item itself now. Because now we want to set the throw parameters. So we go into, from the item itself, under my blueprint, go to the interfaces section, set data. We're going to open up the set item throw params. Now, first thing, we'll just set some throw strength, something around 2500. You can play around with this value to whatever feels good. The throw rotation type, we can set to rotation follows velocity or use rotating movement component. Now, the rotation follows velocity would be useful for like a spear or a forward knife throw, where you would kind of want it to rotate upwards as it's moving upwards and then rotate downwards as it's moving downwards, giving some indication of like gravity influence. The use rotating movement component would be used for something like a shuriken throw, where you want it to rotate all the time. This could also be for axe throws, or realistically anything that you want to have some sense of rotating movement. But for this example, we're just going to use the rotation follows velocity, which also means that we're going to keep the rotation rate unplayed with for right now, as well as keeping save actor for recall unchecked. Now, we are going to add a value to the starting throw rotation adjustment here. However, I want to show you guys what it looks like before we do that, just so that way you can fully understand what this is used for. So if I go and minimize here, click on play. Now I'm going to use the recall that we set up to be able to grab an actor. But now if I go ahead and press E, you can see that he does throw the actor using the montage. However, there are two glaring problems that I'm sure you noticed. First being is that the actor is not facing in the direction of the throw. Even if I face this way, you can see that it's facing kind of towards that way now, which is kind of improper. We want the blade to face in the direction that we're actually throwing. And the second one is just that it's not interacting. But the thing is, we need to set up how we want it to interact. If we want it to attach or sim physics. So that's something that we're going to assign, but the rotation is something we can fix very easily. So if we go back into our item here, and we go into the set item throw params, under the starting throw rotation adjustment, we can see that, we want it to rotate maybe about 90 degrees. So that way, instead of facing this way, it's facing more like this way during the rotation. Right? So what we're going to do is under that value, set the Z value to -90. Now, if we do that, click play, and then I grab one of the knives here, and I throw it, you can see that the knife is now facing forward. Well, it's at least not facing sideways. It might be hard to see that the blade is facing forwards, but it's at least facing in the proper direction there. Now, one thing that is very important is that the system does use overlap events to be able to actually do the calculations for when to stop, attach, sim physics, all that good stuff. So we do want to make sure that all the mesh actors also have some sense of overlap events being triggered. And this isn't something that is defaulted on most Unreal Engine meshes when you add things like cubes and things like that. But there is a really easy way that we can fix that. If we, instead of going in, it's going into each one and going in search and going into overlap, and generate overlap events. Instead of doing this for each individual one, what we can actually do is if we go up into the outliner here and we just type in static mesh actor, you can see that we get pretty much all of the static mesh actors here. However, we do also have the sky sphere. Not really something we want to mess around with. So while in the outliner still, we'll do a space and then a minus and type in sky. And now you'll see that that has been removed from the listing. So this is a way to use the smart search system to be able to only get the static mesh actors, and just like the top one, shift select the bottom one, and now you can generate overlap events for all your meshes. And then from here, we can just save all, save selected, and now we have overlap events ready, so we can start setting up some attach or physics simulation behaviors for our items. So once you've defined, the throwing and the recalling, all of the behavior-based stuff is going to be within the item itself. So we're going to start with a simple attachment first. Now, attachment does require something that SimPhysics does not, which is a socket. And the reason why is because it's a starting trace point to be able to find things like normals and socket positions and other things like that, so the system has some really nice accuracy when it's looking for objects. So if we click on the mesh item here, and then under the details panel, under the static mesh or skeletal mesh, whichever, click on the little folder icon with the magnifying glass. This will actually bring us to the item in our content browser. So then we can double click to open this up. And now from here, we can add a socket. Now, if you're using a skeletal mesh, you can go ahead and just set it to the root bone. However, for a static mesh, we have the socket manager, which allows us to be able to basically free place sockets by clicking the little plus symbol here. Now, we're just going to go and type in a name for it. I'm going to name mine Trace, but it doesn't really matter. You can name it whatever you want. The main thing that's important is seeing this red arrow here. This is the x-axis. In Unreal Engine, the x-axis is always the forward axis. So if I want the trace to run along the blade here, I need to rotate this 90 degrees. So now this red arrow is facing with the blade. So it's very important. You just want to keep that in mind. Whichever direction you want the trace to run in reference to your item, make sure that the x-axis is pointing in that direction. So now we'll just go ahead and save that, and we're going to go back to our item. Now, if we go into the event graph here, and then the component section on the side, we're going to right click on the box, add event, and we're going to add on component begin overlap. And then right next to it, right click, and we're going to search for end throw, and you'll see with attach right here. So we're going to add this in and hook up the executions. Now, as far as what these values are, we're going to go through them one at a time. First thing is the self reference. We can just pull off and get a reference to self by typing self. The ignore actor is going to be the actor we saved up here through the pass-through event. So this is going to be that overlap ignore actor. So we're just going to go ahead and grab that really quickly and plug that into there. The other actor reference is going to be the other actor pin here on the on component begin overlap. The item collision is going to be the collision that the item, the specific mesh will have when the attachment occurs. So for right now, I'm just going to keep it to no collision. And the attach rotation search start socket, this is that socket that we made on the item just before. So we're just going to go ahead and take that. I named mine Trace. So just remember that these are case sensitive. So we need to make sure to name it exactly. Now the attach params and the attach fail backup conditions, we're going to go over these later on. For right now, we'll focus on just these two float values. So the attached check distance, we're going to set this to 40. So again, the trace is running in the forward direction. How far forward do you want that to go? Now the trace is also a sphere trace. So this was what this radius value is going to represent. And I'm going to set it to a value of 5. But you can play around with this however you want. So now that we've defined our kind of base attachment stuff here, the last thing we need to do is under the interfaces set data, we're going to open up the get throw mesh items. And then if we go into the components, we're going to take that collision item, whether you used a capsule, sphere, box, whatever. But we're going to take it, bring it in, and we're going to hook it into the attach collision item. And then we'll compile and save. Now from here, if we go ahead and click on play, and I just grab one of these knives here, and I just throw it out towards that wall there, you can see that we now have the item attaching to the wall. So we got a nice little attachment there, and because we made that reset, I can now grab another one, and I can throw this one at this wall, and now we got some cool attachment and throwing systems set up. So to be able to set up an item that's going to sim physics, it's actually very simple, and it uses a lot of the internal physics simulation stuff that comes with Unreal Engine by default, allowing you to be able to use a lot of the linear dampening stuff, as well as mass and other things that come within the physics state of the mesh itself. And for this example, I do have a grenade mesh here that I've added in, but I did remove the box collision because I just duplicated the other item and removed all of the attach base stuff. So this way we can kind of start off from just a basic setup here. Now what we're going to do is under the static mesh here, you can see we got the grenade, but we do need a collision item still. So I'm going to add a sphere collision to this. And now the reason why I removed and I'm showing you this is because realistically, sometimes the collision item can matter. Something that shapes the item the best. This way it can actually collide with the area in a similar way that the item would, but maybe with just a bit of an expanded area. You can see here that it's slightly bigger than the item. But sometimes, especially with physics simulations, that can actually be a good thing. So we're going to go ahead and just keep it as it is, but we're going to go to the set item throw params, and we're going to set some info here. So first thing is we'll set the throw strength to 2500. The rotation type this time we're going to use the use rotating movement component. And this is just because it adds some nice flair. So we'll set it to just some weird arbitrary values. You can put whatever you want in here. I just kind of type numbers. Now, we're not going to save the actor for recall or do any throwing adjustments, and we are going to use this item for the fuse demonstration as well, but we're not going to do that just yet. Now, the other thing we need to do is go back to the event graph, and we're going to right-click on the sphere, add event, and we're going to do the on component begin overlap event, and then right-click next to it, and we're going to type in end throw with physics. You can see this one right here. Now, this event's a lot more simplistic, as a lot of the stuff that is influencing this physics simulation, Unreal Engine has already provided you. If you go to the static mesh here, in the details panel, and just type in physics, you'll actually see that there's a lot of options with constraints and a whole bunch of different stuff. So a lot of this can be used. The only thing I provided here was a little bit of a bounce option, which I'll show you guys how that works. So if we go to the self ref, pull off, just get a reference to self by typing self. The ignore actor, if we go into the My Blueprint, you can see the overlap ignore actor. So this is that value that we saved up here from the pass-through event. So we'll just take that and plug that into there. And then the overlap actor is going to be the other actor on the overlap event. So just plug that up like so. Now from here, we can go ahead and compile and save, and we'll drag a couple of these in because that's really all we need to do. We just needed to add the behavior event and a starting point. So if I go ahead and okay, so that was, the reason for that was because we forgot to do one step. If we go back into the item, go to the interfaces, set data, get throw mesh items. We forgot to sim physics collision item. We forgot to give it that. So what you saw there is what happens if we don't actually have the collision item being defined. It'll actually try to use the actor itself. So what we're going to do is just take the sphere and plug it into the sim physics collision item this time. And then we're just going to go compile and save, minimize. And then now if we hit play, I should be able to grab, there we go. So now you can see it's still in my hand. Now if I go ahead and I throw this, you can see that it does bounce against that wall, bounced against that wall, but it was kind of a bit of a dead drop, right? Well, this is where that bounce value comes in on the actual end throw with physics function. If I set this bounce to, let's say, actually we'll just do it to a full value of 1 here. And then if I minimize, click on play, bring another grenade up to me. And then if I throw, you can see this time it's got substantially more bounce. Like it comes all the way back to me versus that dead drop. And you can do a maximum of 2. Anything beyond 2, I've noticed that does not actually work. It just kind of like launches the item in a way that cannot be seen. But 2 can be a lot of fun because as you can see here, it bounces it back quite a lot. But realistically, the simulation of physics is a pretty straightforward functionality because everything you need when it comes to collision, simulation starts, and all that stuff is already being handled by the system internally. You're just basically calling the function that sets everything inside. So that's really all you need to be able to simulate physics. Now from here, we're going to take a look at the fuse system and the different ways that you can attach things utilizing the attach parameters on the items. So now we're going to talk a little bit about the fuse system. Now, the way that this is set up is that you can define a lot of different parameters in the system, including the fuse behavior inside of the throw behavior system, or the throw parameters. So inside of your item, if you open up the set item throw params, which just to reiterate, if you go to the My Blueprint section under interfaces, set data, and then set throw item params, you'll see use fuse and fuse params right here, which just to show you as well, we're doing this on the grenade item that we've been using for the demonstration. So the first thing we're going to do is check use fuse, and then we're going to pull off of the fuse params and make s_fuse params. Now there's 3 basic values here. The first thing is the duration of the fuse. So we'll set this to around 5 seconds. The second thing is the start behavior, whether you want the fuse to ignite on throw or when it interacts with a world item. So because it's a grenade, and grenades would release the pin, the safety pin, when you release from your hand, we're going to set it to on throw. And the fuse complete execution preference, we're going to set it to item, but we can also set it to the throwing actor as well. And setting it to the throwing actor, just so you know, is a good way to be able to set up things like remote explosives or other things. This way the fuse can actually be used as sort of like an activation timer. But with these parameters defined and the fuse use fuse checked, we're going to go back into the event graph, go to the interfaces section. Under primary events, you'll see fuse and execute item fuse and start item fuse. We're going to add both of these. Now, we're going to put these execute item fuse out of the way for a minute because this is just like the recall event or any of the other ones. This is kind of like an indicator like, hey, this is a free use execution. We're ready to do things. What do you want us to do? Here, we're going to actually assign the fuse delay and all the important stuff. So next to the start item fuse, we're just going to right click and type in fuse status, and you'll see under the functions here, fuse status. And then we're going to plug in the fuse params, but we can leave these 2 blank. and make sure to set the status to start. Now from here, the fuse timer, we're going to pull off and get a delay node. So just a simple standard delay. And then for the fuse status, we're going to take it, highlight it, and Control D to duplicate it. And we're going to put that off of completed. So it's going to be 1 for the start, and then the end, we're going to select from the status here to make it the end. So this one starts it, this one ends it. Now from here, we're going to take the fuse params out and plug that in. And this is where we do want to take the overlap ignore actor and plug that into there, which is, just to reiterate, this is the value for the actor that's coming from the pass-through event. And then the self reference, we're going to pull off and get a reference to self by just typing in self. And there we go. So that's all we need to do for the fuse. Now to get something to happen with it, from here, we're just going to do a simple spawn system at location. And I think I've got a few explosion systems that I've added here, again, just for, demonstration purposes. And that one will work. Now, a recommendation is that we take this static mesh, pull it off into our graph, pull off of it, and then get world transform. This will give us the world transform of the actual item, because the grenade is going to simulate physics, right? So when it's simulating physics, it's going to detach from the actor itself. So in order to make sure that our emitter is spawning at the right location, I do recommend getting the world transform of the mesh item, because then we can just plug in the return value location, rotation, and then pull off of this and do a destroy actor. So this way, by the time it'll spawn the system, but then destroy the grenade itself. So now if we compile and save, and then if we click on play here, and then I grab one of these grenades, and then if I throw it here, you can see that it bounces off, it's going to roll around, and then here in a second, there we go. So you can see that it removed itself, but the explosion didn't really happen. I think that's just due to the fact that it got the rendering didn't quite take place. So let's see. Yeah, there we go. That time it happened. So there we go. So now we've got a grenade, and I can pick up another one, and I can do the same thing where I can throw it against this wall, have it roll over there, if there was an enemy getting a nice bounce attack, and then boom. So it's a great way to be able to set up timer-based executions, and you can do this in any way you want because the execution for the fuse is actually open. Now, when it comes to attachment, there's a lot of different ways that we can define the actual attachment of an item. Now, the first way that we demonstrated is just basically when we pick up either one of these knives here. If I throw it, it'll go forward and then attach, but it'll just basically use the rotation that it had when we did things. So like when it's going out and throwing, it's just going to use that as its kind of orientation. But what if we go to the My Blueprint section and go to the Set Throw Params, and instead of rotation follows velocity, we're going to set this to the Use Rotating Movement component. And then on the x-axis, we'll just set it to a vector, a rotation rate of 720. Now, if I click compile, save, and then play, and I'll grab one of these knives again, and if I throw it, you can see that now it's rotating, but the item is kind of just gone. I believe it's going to be, it's just inside the wall. Now, the reason for that is a few things. When you're using rotating items, you do have a couple of things that you want to make sure to do in order to make sure it's able to find the area accordingly. So the first thing is we're going to go into our knife mesh here. And remember, we added the socket here earlier in the video when we were setting up the basic attachment system. But because we're now allowing the actor to rotate, this middle point is no longer really a good spot for the trace to start, because it could, it could be in the middle and then it's tracing into the wall. So in order to make it so it has a good distance, we're going to put it slightly behind the handle here, just like this. We're not rotating or changing anything in that regard. We're just moving it backwards a little bit, giving it a bit of a farther distance it can trace. And now if we go back into our blueprint here, and then go into the viewport just so we can see the box collider here, we're also going to make this a little bit bigger as well, because we want this to encompass the entirety of the knife. So we're going to make this just a little bit bigger like that. It doesn't have to be massive, just has to kind of cover the whole area. So now that we've pushed back our socket, increased our search size here, we're going to go to the event graph, and this is where we're going to give it some information so we can tell it, hey, this is how we want it to attach. So off of the event begin overlap and the end throw with attach function, you'll see attach params. We're going to pull off and you'll see make attach params, which will give us all of the attach based information. Now, for those of you who are new, I don't want you to worry. This is not as complex as it might look. It's actually very, very simple. when you want something to attach with a static-based rotation, which ultimately, if you have the item rotating, you're going to want to do because, it could attach in one of 60 different rotations, if not more. As you can see this time, the blade's pointed outward. So there's a lot of different ways that this could happen. So in these situations, if you have a knife and you're rotating, right, it's a good idea to check the static rotation, keep the throw orientation, because this will make it so that way it doesn't try to plant itself just to the item's normal. It'll try to keep the orientation of the throw, but with a sort of offset that you define. So, and the way that we define that offset is in the attach rotation correction map here. So if we pull off and just go make map, just like this, you can see that we can now set X, Y, and Z, and there's also a value associated here at the bottom. Now, how you use this is ultimately going to depend on the item and its orientation. So without overcomplicating essentially what it does, is you can see here that the actor is facing this way. Now, I would want it to face and plant into an item like this, right? I would want it to kind of be, but I'd want it to be, either facing into this item or into this wall or into this wall or into this. And, if they have an angle, I want it to plant at that angle. But, I want it to have this sort of 90-degree starting point. So what I can do, though, is if I open up that blueprint, I can go to the X, which if we also do our quick rotation check, we can see that the X is actually the kind of the rotation vector. If I want it to rotate like this, that's the X vector. So if I look at the X vector, and if I set it to 0, meaning I want this to be 0, I want this so that way it's going to plant like this, right? It's not going to plant like this, or like this, or like this. It's going to plant exactly like this, and then align itself to the normal of the item as well. So, and if you have an item that's, maybe it starts like this, and you want it to end like this, you would just set it to the X to 90. But in this case, we're going to want to make sure to zero out the X instead. So we're just going to keep it at 0, keep it at X. And the item pitch axis is generally speaking going to always be X, but I noticed that there were some instances, depending on the item's orientation, that might change this. And a good way to be able to know what this pitch axis is actually going to be is if you go to your throw item settings and you're using the rotating movement component, the forward rotation, so in this case it's the X, but in some other cases it might be the Y or the Z. Whatever that is going to be the forward rotation or the pitch rotation. So this is where the item pitch axis, you would just set that to whatever the rotation axis is you set for the rotation rate. So just to put it simply, if you're rotating on the X axis, set the item pitch to X. If you're rotating on the Y, set it to Y, Z, set it to Z. That's really all it is. And then for the rotation correction map, again, this is just to kind of make it so that way it'll assign itself a specific rotation. So you can use multiple values too. You can set up X, Y, and Z if you wanted to, but you don't really have to. Generally speaking, with all the items I've tested, one single rotation value seems to be enough. But now if I go ahead and click on play now, grab one of those knives again, and I throw it, you can see that the trace happens and the item, the knife itself, is actually planted perfectly into the wall. And here's the cool part, is that when you're using the static rotation, it also plants it at a specific distance away from the wall. So if I walk up to these, you can see both of these were thrown at different, lengths from the wall itself, but they're both equally planted into the wall. So this allows you to be able to do some really nice consistent plants when you're doing attachments on any item. And if for any reason that you wanted to pull it back a little bit more, remember that we have this socket here and the forward vector is that X-axis. Well, inside of the item itself, you can see that we have the forward and up offsets. And these are actually going to use the socket itself. So if we take the forward axes and we go negative, we'll go negative 10, just to kind of bring it back a little bit, right? If we go ahead and grab a knife and we go ahead and we throw it now, it should be back just 10 units away from the wall, which you can see that it did move it back just that slight little bit. So how you're going to use the attach rotation correction map and all of this is going to change based off of the item. Might require a little bit of playing around, but the main thing to remember is that whatever the axes you want to plant it on, right? So again, if the item is facing upwards like this, right? And you know that you want it to face like this, and that's a 90-degree X on, or 90-degree on the X to make that happen, right? Because the red here is the X axis. So once we know that, all we need to do is assign that to the rotation. So certain items might have different rotation needs, but that's all you're going to really do to be able to figure it out. It's not overly complex. Now the attach fail backup conditions, which can be found on the actual end throw with attach function. This is actually used for in any example where you might be able to, or you might not find a proper item to attach to. And a case in point here is if I take my knife, take any one of these, and I just throw it at the ground here, you can see that the trace runs forward and misses the floor, so it kind of just like, all right, we'll just sit here. Well, what if you wanted it to do something? Well, we can pull off of this and we can go make attach fail params. Now, the one I recommend the most is default to physics, because this one actually allows you to be able to have some sort of movement and dynamics, things that'll happen even if it doesn't attach to something. And we can set the physics smooth velocity to 1. And if we compile and save, click on play, and I grab one of those again, just grab this one here, and then I throw it, you can see that it simulated the physics and just kind of dropped to the ground. Now, the thing to remember too is that if we take a look at the character blueprint here, we have the throw item interacted. Now, this is basically indicating that the throw has ended. Now, whether it succeeded or failed is irrelevant, but you can set a value in if the actor is using physics and it's not supposed to, knowing that the physics simulation is occurring as an override. You can add additional force values and things like that from the item ref itself. So there's a lot of different ways you can define it, but I just realistically, when an item is rotating, it's very, very difficult to make something that's going to always have it plant no matter what is happening, because it needs some sort of orientation direction. So this way, you've got just a nice little physics drop that happens when the attachment doesn't occur. However, you can also set up some sort of value. So if I go to the X and set it to -90, and then I hit play, if I go ahead and I throw this item, you can see that it's actually now facing upwards. So I can set it to +90, and this time it'll face downwards. So this way, if you have a larger item that will actually kind of plant into the ground a little bit, you can then use that to be able to just set a static rotation if it doesn't find something. Now, I am planning on trying to add in something that's going to be a bit more of a better search system, but I didn't want to do like a bunch of traces and a bunch of things that'll overcomplicate things. So ultimately, this is going to be how it is for right now, but it does offer some really, really good principles that allow you to throw and call items with physics simulations and world interactions. But that's really all there is, guys. We've got rotations and attachments, controls, recalls. We can now, take this item and throw it at the wall, and, if it does something cool, if it doesn't, then we're going to go forward. And that actually shows one more thing I actually want to show you guys. You saw that time the knife did not plant into the wall, and that's because if you remember, we moved the socket back on the knife. So when you do this, it is also recommended to adjust the attach check distance. So we're going to set this to 80 instead of 40, and then if I go ahead and click on play, and I grab this knife here, and I throw it, you'll see that it'll actually do the attachment the way it's supposed to. So the issue was mainly just that it didn't have enough distance to go forward. But now that I've given it that extra value, you can see that it's sticking into the wall. And we've also set up grenades, so we can set these and throw them, and, they'll do a nice little controlled explosion, I guess you could call it. There's a lot of different things that you can do and set up utilizing all these different values. So I hope you guys have fun with the system. It is another, just like all my systems, I'm going to keep updating it and keeping things going on it. So let me know if you guys have any suggestions or anything that you feel like could be an improvement to the system. I'm always open to ideas. But that's going to close out for this video, guys. I'm going to be putting out more showing how to be able to set up the animation blueprint setup, as well as other ways that you can set up the system for things like collectibles and explosives, timed remote explosives, projectiles for weapons, a whole bunch of stuff. The system has so many uses, guys. I don't even know if I'm going to be able to make videos about them all, but I'm going to do my best. So I hope to see you guys in the next one. But until then, stay tuned, and as always, stay animated. Remember, we moved the socket back on the knife. So when you do this, it is also recommended to adjust the attach check distance. So we're going to set this to 80 instead of 40. And then if I go ahead and click on play, and I grab this knife here, and I throw it, you'll see that it'll actually do the attachment the way it's supposed to. So the issue was mainly just that it didn't have enough distance to go forward. But now that I've given it that extra value, you can see that it's sticking into the wall. And we've also set up grenades, so we can set these and throw them, and, they'll do a nice little controlled explosion, I guess you could call it. There's a lot of different things that you can do and set up utilizing all these different values. So I hope you guys have fun with the system. It is another, just like all my systems, I'm going to keep updating it and keeping things going on it. So let me know if you guys have any suggestions or anything that you feel like could be an improvement to the system. I'm always open to ideas. But that's going to close out for this video, guys. I'm going to be putting out more showing how to be able to set up the animation blueprint setup, as well as other ways that you can set up the system for things like collectibles and explosives, timed remote explosives, projectiles for weapons, a whole bunch of stuff. The system has so many uses, guys. I don't even know if I'm going to be able to make videos about them all, but I'm going to do my best. So I hope to see you guys in the next one. But until then, stay tuned, and as always, stay animated.